Alright, we're going to do another double replacement reaction. Again, try pausing it and see if you can work your way through the predicting and the solubility rules. Alright, for a double replacement, remember we're going to cross those cations to the new partners. We bring one each over to this side as we combine them with their new anion. So it's 1 to 1, check the charges, right? 1 to 1. I don't care that there was K2 over here. I don't care there was 3 bromines. Bringing one over each. I go and I check the charges. Potassium is a +1, bromine is a -1. That is a balanced compound. Carbonate is a -2 because you have those polys memorized. For me to find the charge on cobalt, I come over here. I notice I have 3 bromines and each of those are -1 charge. And so that means that cobalt has to be a +3 charge. So when I bring the +3 here and the -2 and I crisscross them down, it's going to be CO2, CO3, 3. And as I said before, remember we do not have those charges when we write the balanced compound. Alright, now we use the solubility rules. Have that in front of you. Go to rule number 2 first. That should be rule number 1. Sodium, potassium, or ammonia automatically makes it aqueous. So I go to that one and write aqueous because it's soluble. Don't assume the other one is automatically a solid. If they're both aqueous, on the exam you would write no reaction. You have to make a solid for it to be a double replacement. And who knows, I probably would have that on a test where one of them did not make a solid. And you would be done. You would not have to do the complete or the net ionic because if a solid didn't form. But in this particular one, for a carbonate, it says that it's insoluble, so it would make it a solid. Once I have those products and the solubility, I'm going to balance. Now don't make this any harder than what it is. Pick a spot that's not balanced. I'm going to pick potassium. There's 2 potassiums here. Or I could pick carbonate and balance it by the polyatomics. So here, when I have the 2, I'm going to actually do the carbonate, I believe. I'm going to balance that first. I have 3 carbonates there. So I now have 3 carbonates here. I go back and I recalculate how many potassiums. There's 6. So I'm going to put a 6 in front of here to get that same amount on the other side. I recount now what's in this compound. I have 6 bromines. I need to put a 2 over here to get the 6 bromine. I have 2 cobalts and I have 2 cobalts. So it's balanced. Complete ionic, anything that's an ion, or aqueous I'm sorry, you're going to break that into ions. Make sure you go to the front to count how many cobalt ions that you have. Alright, and I'm going to go to the 2. I have 6 bromines. Don't write it as Br3 with a -1. Bromines only exist as a Br with a -1. So I have 6 of those. I have 6 potassium ions, 3 times the carbonates. I am writing backwards the number 3. Alright, there's 3 carbonates. Go to this side, there's 6 potassiums, so I'm going to the front to multiply that, and 6 bromines, and I make sure that I keep my solid together. Alright, sorry if I'm a little messy here. Alright, and sometimes I underline it to remind myself that it's the solid. If it's on either side of the arrow, we're going to cancel it out. It needs to exactly match the same amount that I have. The ones I'm not crossed out, hopefully are the ones that are involved in the net ionic, which are the ions involved in making the solid. And luckily, that I have that. And there is your double replacement again.